Okay, so like I said, kinematics it is. So there are a total of 4 concepts. Okay, one is time and speed conversion. So this is something that we will just review. Okay, the other is we will learn how to make distance time graphs. Okay, and then we will learn how to make speed time graphs, and then we will learn conversion of graphs, which is not frequently tested. Okay, but it's still part of the syllabus. So maybe what we can do is we can cover the first 3 concepts today and leave this for the next class. Okay, but let's see. Let's see how things play out. So a couple of key points that I'm going to write down from the get-go. Key points. So key point number 1 is that if you have a distance time graph and if you take the gradient of it, what will that give you? And I'll explain this later as well. Okay. Yes, gradient of distance time graph gives speed. Okay, and here we don't use velocity or displacement. Okay, we just use distance and speed. Okay, and another thing to keep in mind is this: the steeper the line, the higher the speed, or you can say the greater the speed.
So you have to carry the distance graph.
Gradient of distance time graph gives speed. The steeper the line, the greater the speed. Okay, or the higher the speed. Okay, key point number 2. Gradient of speed time graph gives what? Acceleration. Okay, now we'll talk about this as well. Okay, for those of you who are doing this for the first time, wouldn't know what I'm saying, so don't worry about it. When we get to speed time graphs, we will discuss this. Yeah, someone saying something? There you go. That reminds me, I should write down the date.
Sir?
Yeah.
Sir, I can't see the notes.
Okay. Is that the same for everyone else?
No.
Acha. So what I'll do is I'll just stop sharing my screen and reshare it. Maybe that will help.
No. Not this notes. The one that you've uploaded in Drive.
Of number sequences?
Uh-huh.
Okay, I'm gonna have to double check. Can I do it after the class, please? Okay.
Yes.
I thought you were talking about these notes. Okay. Anyway, so gradient of speed time graph gives acceleration. All right, we'll discuss this. Okay. So right now I'm just writing it down, so that later on when we get there, you guys know what it means. Okay, and I'll explain this like I said as well. So don't worry about it. Now here's key point number 3, something to keep in mind, and that is area under the speed time graph gives distance travel. Okay, and the shape that you will usually encounter is a trapezium. And Zoya, I just read your message. It's actually a lot easier than physics. Okay, what you guys do in physics is a lot easier than that. And commerce students, don't think that science students have like a major edge in this. They don't. Okay, this topic is not that difficult to begin with. Okay, so even if they do have an edge, the playing field will be level after you also learn the same concepts. Okay, so remember how to calculate the area of a trapezium. Okay, you guys remember how to calculate the area of trapezium? It's half into
Side 1 plus side 2. Sum of parallel sides into height.
yeah, half into sum of parallel sides into height. Okay, now you can encounter 2 types of trapeziums. Okay, one where the parallel sides are horizontal. Okay, like for example you can have something like this. So in that case, this is, let's call this length 1, let's call this length 2, and what's the height going to be? Height, as we know, is just the perpendicular distance across the 2 parallel sides. Okay, so you can encounter something like this, or you can come across something like this where the parallel sides are vertical. Okay, so in either way, the formula that you're going to use remains the same. Okay, half into sum of parallel sides into height. So here's L1, here's L2, and here's H. Okay. So area equals half into L1 plus L2 into H. Okay. Now, at the moment, I don't expect you to fully understand everything that I've written over here, but do keep it in mind, sort of make a mental note of it, so that when we, for example, when we're doing distance time graph and we have to calculate speed, you know what we have to do. Okay. But when we get there, I will explain it again as well. All right. Now, like I said, there are four concepts. This is like a prerequisite. Okay. So we will just quickly go over this. In this, we just need to learn how to break down time in hours and minutes and in decimals. Okay. So that's what you need to learn. So we'll just do two examples of each, and that should be good enough. So let's say. Yeah, we have done this. Both the batches have done this, but we'll just do a quick review of it. So let's say that you have 2 hours and 45 minutes. Now, can you calculate the decimal value of this? It's going to be 2 point something. Why? Because it's 2 hours. Now, how will I calculate the point something part? For that, what I need to do is you need to look at the number of minutes. That's 45. And if I want to convert minutes to hours, what do? We divide by 60, which is equal to 0.75. And now you have 2.75 hours. That's what 2 hours and 45 minutes is equal to. Okay. Now the question is, when do we have to do this? So for example, if let's say you have to calculate the distance, okay, and you have the speed and you have the time, but you have the time in this way where you have 2 hours and 45 minutes. So obviously you can't keep 2 hours and 45 minutes over here. You need to know what this is going to be in decimal. That means you need to convert it to decimal before you can cross multiply or do whatever it is that you have to do. If you have to find the speed using distance and time, then also you're going to use 2.75 and you can't use 2 hours and 45 minutes. Okay. Let's say, on the other hand, let's say that you have 4.6 hours. Okay. And now you need to find out how long is 4.6 hours in hours and minutes. So it's a no-brainer that 4.6 hours in hours will be 4 hours. So ahead of it's 4.6, so it has to be 4 hours and something. Now the question is, how do we figure out that and something? For that, we look at the decimal, so that's 0.6. So 0.6 of an hour is how many minutes? For this, we multiply it by 60, so that's equal to 36. So that means this is 4 hours and 36 minutes. Again, something that we have done already. Okay, so this is just a recap of that. Okay. Now, another thing is that you need to know is how to convert speed. Okay. Now, this is a mixture of two conversions. One is converting kilometers to meters, and the other is converting hours to second. So, if let's say you have to convert kilometers per hour to meters per second, what do? You multiply it by 1000 upon 3600. Okay, this is something that you can just memorize. Okay, but do understand why we're doing what we're doing, because we're going from kilometers to meters. So for that, we multiply by 1000, and we're going from hours to seconds. So for that, we're also multiplying the denominator by 3600. Okay. Now, what if it was the other way? What if let's say you had to convert? Yeah, that's correct. Meters per second to kilometers per hour. In that case, you would divide by 1000 upon 3600. But when you change this division to multiplication, this becomes 3600 over 1000. Okay. Now, so far, any questions? Any questions regarding the conversion or converting speed? Yes. All right. Now, the next concept is, Moise, there is a calculator function for conversion. Okay. Well, yeah, for IGCSE students, you guys really don't have to learn this. You can just use your calculator. But still, in fact, I would say that it's important for, irrespective whether you're an IGCSE student or an O-level student, it's best that you learn how to do it. Okay. Now, whether you do this using a calculator, as in whether you do in 2000 upon 3600 using a calculator or not, that for O-level students depends on where this question comes in paper 1 and paper 2. But IGCSE students, you guys can just use your calculator. But do keep in mind that in some cases you still have to show your working. Okay, so now we're doing distance time graphs. Okay, as far as the conversion is concerned, that's all there is. Okay, but now we're doing distance time graphs. Okay, now Distance time graph, as the name suggests, you have distance on the y-axis. Okay, could be in kilometers, could be in meters, doesn't matter. Okay, and you have time on the x-axis. Again, could be in hours, could be in seconds, doesn't matter. Okay, so let's say, okay, so here's the scenario. Let's say this is going to be a distance time graph of a person who's leaving his house, going to watch a movie, and then coming back. Okay, so क्या हो रहा है? घर से जा रहे हैं to watch a movie, and then they're coming back home. Okay, so we have time, which is going to be in hours, and we have the distance, which is going to be in kilometers. And we're not going to use actual values, we just need to understand the shape of the graph. Okay, and then sort of decide that what each part of the graph represents. Okay, so here's the starting point, which is O. Okay, now the second you leave your house and you're heading towards the cinema, so what's going on between you and the distance from the starting point, which is your house? What's happening? Is it? It's increasing. Okay, so this is your starting point. Okay, which let's call it home. Okay, and you're heading towards the cinema. So the distance is increasing. Okay, now let's say there comes a point where you've reached. Okay, let's call these values t1 and d1. Okay, so t1 and d1. Okay, now when you reach the cinema, okay, and the movie starts, and now you're watching the movie. So while you're watching the movie, what exactly is happening to the distance? Okay, the distance between you and the starting point. Is it increasing? Is it decreasing? Is there no change? There is no change. Okay, it's not like your house is moving, okay, or the cinema is moving. Okay, you're both stationary, so that means the distance from the starting point will remain the same. Okay, now let's say this is the point where the movie ends, you're leaving the cinema, and now you decided to come back home. So if you're coming back home, what will happen to the distance from the starting point?
Decrease.
Yes, it will decrease. Okay, it will decrease, and there will come a point when you're back home, and then your graph will be touching the x-axis, which means that distance is 0. That means now you're back to the starting point. Okay, now let's break this part of the journey down. Okay, let's call it OA. Let's call these points OA, BC. Okay, now from O to A, let's see what's happening. From O to A, the distance is increasing. Okay, but we don't just leave it there. We don't just leave it there that the distance is increasing. We say the distance is increasing at a constant rate. Why is that? Why is the distance increasing at a constant rate? Because it's a straight line. Okay, the steepness of the line is not changing. So this is a straight line from O to A. That means the rate of increase of distance is constant. And what is this constant rate actually? This constant rate is actually, yes, this constant rate basically means what? That the speed is constant. Okay, now notice what I said earlier. I said the gradient of distance time graph gives what? The gradient of distance time graph gives speed. Now let's see why that is. Now what's the formula for calculating gradient? What is the formula for calculating gradient? It's y2 minus y1 over x2 minus x1, right? y2 minus y1 over x2 minus x1. Now in this case, what do we have on the y-axis? We have distance. So that means if I do y2 minus y1, I will have basically the change in distance. Okay?
Excuse me, sir.
Yes?
Sorry to disturb you. I just joined. So what are we doing today?
We're doing kinematics. Okay? We're doing travel graphs. Alright?
So the kinematics is same as like in physics, or it's different?
It's easier. It's easier than physics. Okay? Alright. Now, as I was saying, so if you take the gradient of distance time graph, what does that mean? That means y2 minus y1 over x2 minus x1. So when you do y2 minus y1, you end up calculating the change in distance between 2 points. When you do x2 minus x1, let's say you take the difference between these two x values, what do you end up doing? You actually end up calculating the change in x between 2 points. And what is distance upon time equal to? Distance upon time is equal to what?
Speed.
Is equal to speed. So that is why the gradient of distance time graph gives speed, because when you calculate the gradient in the numerator you have distance, in the denominator you have time, and distance upon time, as we know, is equal to speed. Okay, now what's happening from A to B? A to B, the distance is not changing. Okay, or you can say the distance is constant, not changing, not increasing, not decreasing, whatever it is that you want to say. Distance is not changing. Okay, so what can I say about the speed? What can I
Speed is 0.
It's 0. Why is the speed 0? Okay, like for example me sitting here. Okay, let's say we mark any starting point. Okay, so as I'm sitting here, my distance from whatever that starting point is not changing. Okay, so what's the speed? It's 0. So if the distance is not changing, you can see that as time is passing, the distance remains the same. That means speed equals to 0 kilometer per hour. Okay, or in physics, as we say, what do we say? Object at rest, stationary,
Stationary.
stationary. Okay, object at rest or stationary. At rest basically means not like literally resting, but like speed is 0. Okay. All right. What's happening from B to C? B to C, the distance is decreasing. How do I know it's decreasing? Because it's a downward sloping line. The distance is decreasing, and it is still decreasing at a constant rate. And this constant rate means what? This constant rate means that the speed is constant. Okay. All right. Okay. So this is a breakdown of a distance time graph. Okay. So take a good look at what I've done. Let me know if you have any questions. We will do some questions of distance time graphs so that we learn how to make them as well. Okay. But if you have any questions, feel free to ask.
Sir, are we just supposed to analyze our distance time graph in the paper?
So there are multiple types of questions. In some cases, you have to make a distance time graph. In some cases, it's partly drawn, you have to complete it. In some cases, it's completely drawn, and then using the distance time graph, you may be asked to find the speed. You may be asked to convert it into a speed time graph. Like I said, conversion of graphs is also part of the syllabus, but it's kind of rare. So, yeah, could be all sorts of
How
things.
many marks are these questions?
So, kinematics altogether, you can expect it to be around. All right, I will share paper 1 questions as well as paper 2 questions, so you'll notice that it can swing either way. Okay. If it doesn't come in paper 1, you can be damn sure that's going to come in paper 2. If it doesn't come in paper 2, that means it's probably came in paper 1. All right. So, and I'm not making any guesses. I don't give guess papers or anything like that. It's just common sense. So here's question 1. It says a cyclist set out at 0900 for a destination 40 kilometers away. Okay. Now, first thing you need to do is you need to read the question. Okay. तसल्ली से पहले आपने सवाल पढ़ना है before you do anything else. So a cyclist set out at 0900 for a destination 40 kilometers away. He cycled at a constant speed of 15 kilometers per hour. All right. So I would underline constant speed because constant speed on a distance time graph looks like an upward sloping line if he is moving away from the starting point. Okay, which he is because he set out for a journey which is 40 kilometers away. Okay. So he cycled at a constant speed of 15 kilometers per hour until 10:30. Okay. Then he rested. So we all know what rest looks like on a speed distance time graph. It's like a horizontal line for half an hour before completing his journey at a constant speed of 20 kilometers per hour. Okay, so these are major hints that I've underlined. And then, of course, you have important values as well, such as 40 kilometers, 15 kilometers per hour, 10:30, 900, 20 kilometers per hour. Okay, now, so you can say that his journey is divided into 3 parts. Okay, one where he is cycling at a constant speed of 15 kilometers per hour, the other where he is at rest, and the third where he is again cycling at a constant speed of 20 kilometers per hour. Okay, now the total journey, as we know, is 40 kilometers. Okay, and here is the time, which is in hours. Here's the distance, here's the time. Okay, so from 0900 to 10:30, how many hours and minutes is that?
1 hour and 30 minutes.
1 hour and 30 minutes. Okay, so speed is 15 kilometers per hour. Okay, time as you said, is 1 hour and 30 minutes. Okay, so with the help of this, with the help of speed and the time, what can I work out?
We have to find out the distance.
We can work out the distance. That's correct. And distance, as we know, is speed into time. Okay, as we should know, speed into time. But the thing is, now we've hit a problem. We have 15, but what do I multiply 15 with? 15 to chalo speed, okay, but 1.5 exactly. Okay, so now that is the reason why these conversions are important. Okay, so that you know how to convert hours and minutes to hours and decimals only. Okay, so 15 into 1.5 is what, 22.5. Okay, so there you go, 22.5 kilometers. So that means when he set out at 0900, by the time it was 10:30, he had already covered a distance of 22.5. Okay, so by the time it was 10:30, he had covered a distance of 22.5. Okay, so that means at this point here we have 10:30 and this time is 22.5. Oh, sorry, this distance is 22.5. Okay, now before I do the next part of the journey, if you guys have any questions, feel free to ask. Now the next part of the journey says then he rested for half an hour. Okay, so it's 10:30 right now. If he starts resting now and he rests for half an hour, so what time will his rest end? 11. Okay,
11.
so that means by the time he was ready to go again, it was 11 o'clock. Okay, so this is the second part of the journey. Okay, now this is where things get slightly interesting. We know what the speed is at which he's going to cover the remaining distance, which is the speed is 20 kilometers per hour. Okay, we don't have the time, and surprisingly we also don't have the distance. I mean, we don't have the distance given to us. So what am I going to do now?
40 minus
Yes.
22.5.
Yes. So we know what the remaining distance he has to cover, because the question told us in the beginning that the journey is 40 kilometers long. He has already covered 22.5. That means now there's just 17.5 kilometers to go. So we have the distance. Okay. So I was just joking that we don't have the distance. We do have the distance. Now we can work out the time, which is equal to what? Distance upon speed. So yeah, speed equals to distance. I hope you guys know how to convert this formula. Speed equals, वो क्या था आप लोगों ने इस तरह से याद कि if you want the speed, you cover the speed, you have distance upon time. If you want the distance, you cover the
Yes, sir.
distance, you have speed. And then if you want the time, time equals to distance upon speed. Okay. Now, so distance is what? Distance is 17.5. The speed is 20. Now, here's a small problem, and you should, with practice, you will be able to anticipate this problem. When I work this out, this will give me the time, no doubt, but this will give me the time in hours and in decimals. Okay, but here I need to know what the time was, as in like the actual time. Okay, the time that the clock was reading. So what do I need to do? All I have to do is multiply it by 60. Perfect. So if I multiply it by 60, 21s are 20, 23s are 60, 17.5 into 3 is 52.5. Very good. Okay, what does that mean? That means that, chalo, you guys tell me, what does that mean? What does this 52.5 really mean over here?
At 11:52.5, he reached, completed his journey. of
Yep.
40 kilometers.
That is correct. So basically, by the time he completed his journey, the clock was reading 11:52.5. Okay, so there you go. 11:52, and 11:52.5 basically means 11 hours 52 minutes and 30 seconds. Okay, so that's it. Part 1 done. Okay, you can expect this to be like a 2-mark question or a 3-mark. Just a minute, Deva. Let me answer this question first. Why did you multiply by 60? Okay, so the reason why I multiplied by 60 is so that so this is going to be 0 point something, right? Because the numerator is lesser than the denominator. So 0 point something is not really going to help me. So I need to know how many minutes that is. So for that, we're multiplying it by 60, so that if he sets off at 11 and he takes 52.5 minutes, so we now know that the journey ends at 11 hours 52 minutes and 30 seconds. Okay, so here's part 2. Tell you guys, give me the answer to part 2, although I've done all the hard work.
11:53.
11:53 it is. That's it. Good job. Okay, So let's do one more question so that we further get the hang of distance time graphs, and when we do get the hang of distance time graph, we will do speed time graph, inshallah. Okay. All right. So here's another question. Let's see what it says. It says Raj starts a 30-kilometer journey at 0900. He maintains a constant speed of 20 kilometers per hour for the first 45 minutes. So immediately there's a catch in the question. Okay. So it's best that you underline it. Constant speed for first 45 minutes. Okay, I'll ask you guys what the catch is later. First, let's read the question. And then stops for a rest. Okay, so let's underline that. He continues his journey at a constant speed. Let's underline that as well. Finally arriving at his destination at 11:20. Okay. Find the distance traveled in the first 45 minutes. Okay, so let's do that. Distance, as we know, is speed into time. So what am I going to do? Am I going to do 20 into 45? Is that correct?
20 to 0.75.
Yes. Where did the 0.75 come from?
So convert the 45 minutes into hours.
Okay. Now the question is, why exactly are we doing that? You're right. The question is, why exactly are we doing that?
So the speed is in kilometers
Yes.
per hour.
Okay. So the units have to be the same. You're right. Since the speed is in kilometers per hour, that means the distance has to be in kilometers and the time has to be in hours. Okay. So here, since we have to work out the distance, that means the time is going to be in hours. Okay. So you can just do 21s are 20, 23s are 60, 45 upon 3 is 15 kilometers. So that means in the first 45 minutes, Raj covered 15 kilometers. Okay. Now here comes part 2, where you have to draw the distance time graph to represent the journey. Okay, let's do that. Let's draw the distance time graph. So do we know the total? Yes, we know the total number of kilometers. That's 30. Okay, and he sets off at 0900. Okay. Now when 45 minutes have passed, that means when it's 9:45, he has covered half the journey. How do I know it's half? Because 15 is half of 30. Okay, so that means in the first part of the journey, he has covered 15 kilometers. Okay, there you go. Because the question says it's constant speed, that's why we have an upward sloping line. Okay, then he stops for a rest, and the question doesn't tell you how long he's resting for. But if he is stopping for rest, then what is the graph going to be like for that part where he's resting?
It will be a horizontal line.
It will be a horizontal line. That's correct. Now we don't know how long
Straight
he's.
line.
That's correct. A horizontal line. Okay. Now we don't know how long he's resting for. Okay. In fact, if you read part 3, you'll notice that's what you have to find. Okay. But that part comes later. What we do know is that the remaining part of the journey he covers at a constant speed, and when he eventually ends his journey, it's 11:20. Okay, so that means now we have to work backwards. Okay, now let me tell you what I mean by that. So here's what we know. We know that by the time his journey ends, it's 11:20. Okay, and up until here, it was 9:45. Okay. Now, if let's say somehow, okay, we don't know how yet, but let's say somehow we're able to calculate how long it takes him in the last part of the journey. Okay, how long does it take him to travel the remaining distance? That should help us to calculate the amount that he's rested for. Okay, hypothetically speaking, I don't know if that's what the answer is, but let's say if it turns out that it takes him 20 minutes, okay, to calculate the remaining part of the journey. So that means this is 20 minutes. So after traveling for 20 minutes, it was 11:20. So that means his rest ended at 11 o'clock. And then we can see how many hours and minutes from 9:45 to 11 o'clock. Okay. So that's what the idea is. The idea is to somehow find out what this duration is. And then with this duration, we'll find out what this time is. And then after we have this time, we will just calculate the difference. Okay. Now, if you look at this is part 2. All right. The working for part 2 is over here. If you look at the final part of the journey, you can see, let me use the color blue. Okay. You can see that we don't have the time. Yes, we don't. But we do have the speed, which is given over here, constant speed of 30 kilometers per hour. Okay. And what about the distance? We also
15.
Yes, we do have the distance. It's 15. Okay. So what can I do with this? I can work out the time. time, as we know, is distance upon speed. So time is 15 and speed is 30.
On 30.
So 15 upon 30 is 0.5. So 0.5 hours is how many minutes?
30 minutes.
Is 30 minutes. Okay. So now we know the duration of the last part of the journey. That's 30 minutes. Okay. So now let's work backwards. If after traveling for 30 minutes, he stopped at 11:20, so at what time did he start?
10:50.
10:50. That's correct. So I hope everyone understands this. So 11:20 is, think of it this way, it's a 30-minute drive, and after that 30-minute drive, you reach to your destination at 11:20. So that means you must have started at 10:50. Okay. So 11:20 minus 30 is what we're doing. Now can we calculate the duration of his rest?
1 hour 5 minutes.
1 hour 5 minutes is correct, except it's not. Read the question.
It's 65 minutes.
65 minutes. Okay. So you can lose marks if you say 1 hour 5 minutes, because the question is strictly asking for the answer in minutes. Okay. So what you've done isn't wrong, but you'll lose a mark basically. So yeah, there you go. Here is another example of a distance time graph. Take a look at it. Let me know if you have any questions. I will give you guys a question where the distance time graph is made, and I just want you guys to solve the following parts. So I'll make these arrows to make your life easy. Okay, now, so part A. Without carrying any calculations, state which of the journey's two stages was at a higher speed. First stage or the second stage?
Second,
Why the second stage?
steeper gradient.
Line
Yes.
steeper.
So if you remember, key point number 1, the steeper the line, the greater the speed. Okay, now you didn't really need that key point to figure that out, I'm sure. Gradient, as we know, is a measure of how steep a line is. So zahir si baat hai, if a line is steep, that means the gradient will be higher, and gradient here is representing speed. Okay, so clearly it's the answer is that it's the second stage. Okay, and then you can give an explanation that it's a steeper line. Steeper line. Okay, how far did he travel in stage 1 of his journey? The first 30 minutes? 2 kilometers. That's it. Okay, and then let's write that down. 2 kilometers. Okay, then it says what was his speed in kilometers per hour for the first stage?
4 kilometers per hour.
4 kilometers per hour is correct. So basically, this is part 2, B part 2. Speed, as we know, is found by taking the gradient of the distance time graph. So you can see that the change in y is 2 and the change in time is 30 minutes. So obviously we're not going to take 30, we're going to take 0.5 because we have to give the speed in kilometers per hour. Okay, great. What about part C? 12 kilometers per hour it is. Okay, so basically in part C we are calculating the gradient of this line that I'm highlighting in blue. So what's the change in distance? You can see it's from 2 to 5, so that's 3. Okay, and what's the change in time?
0.25 hours.
0.25. Why? Because in between 8 and 8:30 you'll find 8:15, and from 8 to 8:15 is 15 minutes, which is 1 upon 4. So 3 divided by 1 upon 4 is going to be 3 upon 4, which is 12 kilometers per hour. Okay, now as always, take a good look at it. Let me know if you have any questions. If you don't, then we're starting speed time graphs. Well, don't get your hopes high. It will get slightly more complicated. Okay, abhi to dekho, we're just learning the basics. Okay, once we've learned the basics, then we can apply it to any question there is.
Sir, at least physics se better hi hai.
Yeah, like I said, it's a lot easier than physics. So there are difficult parts to this. There will be difficult parts to this question. Overall, itna mushkil nahi hoga, okay? But you know, here and there you might find a challenging part. So we're gonna make a speed time graph of okay. So I'm sure you guys haven't done it, but sure must have seen it. You've seen people skydiving, right? So imagine this, that we're making a speed time graph of a skydiver. Okay, so here's the time in seconds and here's the speed in meters per second. Okay, now So the second he jumps out of the helicopter, what happens? Helicopter or plane, whatever it may be. What happens to the speed? Speed starts to increase. Okay. So the speed is increasing. Okay. Acha. Now, for those of you who have done physics would know this, but for those of you who haven't, you must have noticed that every time a skydiver jumps off an aircraft, वो jump करते ही parachute नहीं खोल देता. क्यों नहीं खोलता ऐसे? Why is that? Why isn't it that the second they jump, they pull the parachute? They always free fall for a few seconds. Why is that?
So your resultant force needs to be zero.
Yeah.
constant velocity में पहले पहुंचे.
Yes. Okay, but why do they need to reach a constant velocity? Chalo, let me ask you that.
Like वरना फिर उसके बाद क्योंकि वो आपकी ड्रैग इंक्रीज कर रही होती है और फिर वो पैराशूट को ना फाड़ दे.
Yeah, I get that. He has to reach an equilibrium. Okay, but my question is. Okay, so the thing is, अगर वो jump करते ही parachute खोल देगा ना, तो फिर Nabil has said that it will take him too long to come down. Okay, in fact chances are कि वो ऊपर ही रह जाएगा. ठीक है, not like outer space में चला जाएगा, but chances are that he'll find it difficult to find that momentum which is going to bring him down. Okay, so that's why the second they jump off from an aircraft, they free fall, not necessarily from an aircraft. Okay, if let's say there's a significant height, so they free fall for a few seconds and then they pull the parachute. Okay, so here's your parachutist who is free falling. Okay, now he's going to free fall for a few seconds. Okay, and after he is done free falling for a few seconds, what will happen is he will reach constant speed. Okay, now I know in physics we use velocity, but here we're gonna stick to speed. Okay, so this is the point where he's reached constant speed. Now he is gonna keep on falling down for at a constant speed for a few seconds. Okay, and then this is the point, let's say, where he pulls the parachute. Okay, so this is where he has reached maximum speed. Okay, this is the point where he pulls the parachute. So what happens then? The second he pulls his parachute, yes, the speed starts to decrease. Okay, that's what the whole idea behind a parachute is. Okay, so the speed starts to decrease. Okay, and it's going to keep on decreasing, and this is the point where he hits the ground. So the second he hits the ground, what happens to the speed? Speed is 0. Okay, now so let's, just like how we did with the distance time graph, let's do the same with the speed time graph. Okay, so we have 3 parts of the journey: OA, and then from A to B, and then from B to C. Okay, now what's happening from O to A? Let's write that down. O to A, we can clearly see that speed is increasing, but again, we don't just leave it there that speed is increasing. We say speed is increasing at a constant rate. And what is this constant rate? Previously it was distance that was increasing at a constant rate. Okay, and the constant rate was speed. Here, let's go back to the key points. Yes, gradient of speed time graph gives acceleration. Okay, so here when we say speed is increasing at a constant rate, this constant rate is basically referring to acceleration. So A acceleration. Okay, so I'm just going to save some time by not writing the entire word acceleration. Acceleration is constant.
What is the difference between acceleration and speed?
Acceleration and speed. Okay, that's a very good question. I'll answer that. Okay, when we just give me a minute, let me write this down and I'll answer that question. Okay. Okay, so AB, what's happening from A to B? Let's write that down. A to B, you can see that the speed is constant. Okay, and if the speed is constant, that means that the acceleration is 0. Okay, acceleration is 0, and the unit for acceleration is meter per second square. Okay, which I'll explain why. All right, and now what's happening from B to C? Let's write that down. B to C, you can see that the speed is decreasing, but again, we don't just leave it there that the speed is decreasing. We say speed is decreasing at a constant rate, and this constant rate is referring to deceleration. Okay, so deceleration is basically negative acceleration or deceleration. Okay.
सर इसका एक और लफ्ज भी आता है.
Retardation.
Yes.
Okay. Yeah, or you can say retardation. Although I still find it difficult to wrap my head around why they call it that. I mean, why they have to use such a word. Khair. So
बस CI वाले हैं ना.
now let's talk about acceleration has magnitude and direction both, while speed has magnitude only. Okay, that's true. Okay. Now let's look at it formally. Okay, let's understand what acceleration really is. So you know how what speed is. So if you break down speed, let's say you're traveling at a speed of 20 kilometers per hour. Okay, if you break it down, 20 kilometers per hour, that means every hour you're covering a distance of 20 kilometers. Okay, that's what speed is. 20 kilometers per hour. Okay, it's the rate of change of distance. Okay, it's telling you how the distance is changing with respect to time. Okay, acceleration on the other hand is basically the rate of change of speed. It tells you, or velocity. It tells you how the speed is changing with respect to time. But here we're going to stick to speed. Okay, so that is why the gradient of speed time graph gives you acceleration. Okay, now let's further understand this with the help of this example. Okay, now let's say that you're at a point t equals to 0. In fact, let's say you're standing at a light, okay, and the signal turns green. Okay, now the second the signal turns green, obviously what you're going to do is you're going to start to increase the speed. Okay, you're going to start moving. Okay, and then just ahead you notice that there's a red light. Okay, so what are you going to do before, like, leaving a safety distance before the red light? What you're going to do is you're going to apply the brakes. Okay, let's say this is the point where you apply your brakes. Okay, and then eventually the idea is to come to a stop at this red light. Okay, red light, green light. Now let's see what's happening to the speed during this journey. Okay, so here I'm going to write down the time, and here I will write down the speed in meters per second. Okay, so at 0 seconds your speed is 0. Okay, let's say a second passes and now your speed is 2 meters per second. Okay, let's say another second passes by and now your speed is 4 meters per second. Let's say another second passes by and now your speed is 6 meters per second. Okay, sorry, not centimeters per second, meters per second. Just like that, let's say another second passes by, now your speed is 8. Another second passes by, now your speed is 10. Another second passes by, now your speed is 12. Now, do you notice something? Every second, the speed is what? The speed is increasing. Okay, now answer this. Every second, is the speed increasing by the same value or is it increasing by a different value? It's the same value. Okay, so what do we say over here? We say that the rate of change of speed is constant. And that rate of change, what is that rate of change? Look at the values. Tell me what that rate of change is. 2, exactly. So rate of change of speed is constant. And every second the speed is increasing by what? Every second the speed is increasing by 2 meters per second. So what does that mean? You take any two values, okay, any two. Let's say aap ye do le lein, okay. Now you calculate the change in speed, which is 2. You calculate the change in time, okay. Now what is the unit for speed? It's meter per second. What is the unit for time? It's second. So that is why when you simplify this, meters per second divided by second, what you end up with is this, meter per second square. Okay, so technically what's happening in the background is this, that you are doing meter per second divided by second. So meter per second into 1 upon second, and that's why you get meter per second square. Okay, so this 2 meters per second square is telling us what? This 2 meters per second square is telling us that every second the speed is increasing by 2 meters per second. Okay, so I hope that helps you understand what acceleration really is. Now let's say at 7 your speed is still 12. At 8 your speed is still 12. Okay, at 9 your speed is still 12 meters per second. But let's say at 10 you've decided that at 9, let's say you've decided that you're going to hit the brake. So your speed at 10 is 8 meters per second. Your speed at 11 is 4 meters per second, and your speed at 12 is 0 meters per second. Sorry, I've run out of space. But anyway, so for as long as the object is traveling at the same speed, what can we say about the acceleration? If I ask you that during this duration, what is the change in speed? Or let's say, what is the acceleration? So what are you guys going to say? It's 0. Okay, because there is no change in speed, so acceleration is 0 meters per second square. Now, if I ask you this, that during this part of the journey, what is the acceleration? So what are you going to say? You're going to say it's -4. Okay, and what does that mean? That means every second, the object is decreasing its speed by 4 meters per second. Okay, hence we have -4 meter per second square. Okay.
सर
हाँ जी बोलें बोलें
अगर पेपर में लिखा हो कि आप एक्सेलरेशन नोट करें तो -4 लिखेंगे और अगर डिसेलरेशन
Yeah.
4 लिखेंगे.
So if it's like stating loss, you know, when we say loss, we don't write it with the minus sign. Why? Because the word itself is self-sufficient. Just like that, if the question is, let's say you end up with acceleration, which is negative, and the question is asking you to write down the deceleration, then obviously you don't put the minus sign. Okay, you give it without the minus sign. So here's an example question. Let's do this. Let's see what it says. It says the graph shows the speed time graph of a car. Okay. Find the acceleration in the first 2 seconds. All right. So what is it of the speed time graph that gives you acceleration? The gradient. Very good. And in order to find out the gradient, you need 2 points, which you have. Okay, you have these 2 points. Okay, the point of the coordinates of this point is 2, 10. The coordinates of this point is 0, 0. So now you can find out the acceleration very easily. 10 minus 0 over 2 minus 0, 10 upon 2 is 5. So 5 meter per second square. Now you don't have to worry about writing the unit. As you know in math, it's given to you next to the space where you write down your answer. Class till 6 or 6 7 tak nahi hai. It's still 6. Okay. Part 2. Part 2 says, given that the distance traveled is given by the area under the speed time graph. Okay, so here the question is nice in the sense that it has told us how to calculate the distance traveled. Okay, it is through the area, but that's something that you guys should know anyway. Okay, don't expect the question to tell you this every time. So key point number 3, area under the speed time graph gives distance traveled. Okay, now if you look at this shape, what shape is this? If I want to calculate the area under this graph, what shape is this? It's a trapezium. Very good. Okay, so that means I need to calculate the area of this trapezium. So are the parallel lengths horizontal or vertical?
It's the horizontal line.
Yep, horizontal. So area equals to half. I'm not going to write down the formula. Okay, let's immediately find out the sum of parallel sides. Okay, or let's start with the parallel sides. So here's one side. Okay, and this is going to be 6. Here is the other. How long is this going to be? 3. Kaise? From 2 to 5. Okay. So that's going to be 3. So 6 plus 3 into the height. What is the height going to be? 10. Good job. Okay. So 2 1s are, 2 5s are. 6 plus 3 is 9. 9 times 5 is 45. Okay. Now the question doesn't end there. Okay. You now have to calculate the average speed. Achha, oh, here's one formula which I forgot to write down. Okay. How do you calculate the average speed? You can say this is key point number 4. Yep. That is exactly why I didn't write it down, because I assumed कि आप लोगों को पता होगा. So average speed equals to, I'm just kidding, I totally forgot about it. Total distance upon total time. Okay, it doesn't matter whether speed was constant or not, or whether the object was accelerating, decelerating, doesn't matter. Okay, so we have the total distance, that's 45. Okay, what about the total time? Do we have that? It's 6. So 45 upon 6, let's work that out. 7.5. 7.5 meter per second. So there you go. That's it. That's your answer. चलिए ये सवाल कर लेते हैं, फिर हम एंड करते हैं, बिकॉज ताकि हमारा एटलीस्ट स्पीड टाइम ग्राफ कंप्लीट हो जाए, एंड देन इन द नेक्स्ट क्लास वी कैन डू कन्वर्जन ऑफ ग्राफ्स, एंड देन इन द क्लास आफ्टर in fact, in the same class where we do conversion, we will also do past paper questions. Okay. The diagram shows the speed time graph of an object which travels at a constant speed of 36 meters per second and then slows down at a constant rate of 12 meter per second square, coming to rest at time t seconds. Okay, so slows down at a constant rate of 12 meter per second square. What is that? What is this? This is basically acceleration. Okay, so this is acceleration. Now if I write this as acceleration, so that's going to be minus 12 meters per second square. Yes, you're right, we haven't done, you guys haven't done trigonometry either. Anyway, don't worry about that. So this is minus 12 meter per second square. Okay, why is it minus? So notice that the question has given you the slowdown rate. So if we talk about that in terms of acceleration, that is going to be minus 12 meter per second square. Okay, now technically what do we have? This minus 12 is technically what of this line? Gradient. Deceleration, I agree, but it's also the gradient. Okay, so that means we have 2 points. One of them is 6 comma 36, the other is t comma 0. What we have is basically the gradient of this line. So if I find out the gradient of this line, I will do y2 minus y1, okay, over t minus 6. And what is that equal to? That's equal to minus 12. Okay, so let's work this out. Minus 36. In fact, a काम करो. 0 minus 36, you can straight away write it as minus 36. Cross out the minus sign. Okay, that will make life easy. And if you want to make life even easier, so you simplify 12 and 36. 12 ones are, 12 threes are. So 3 is equals to t minus 6 after you cross multiply. 3 plus 6 is 9, so 9 equals to t. So t equals to 9 seconds. This is what we had to do in the first part. There you go, t equals to 9. Sir, how many formulas do we have to remember in this topic? Okay, remember, so there aren't formulas, there are just key points. Okay, as far as the formula is concerned, just remember speed equals to distance upon time and area of trapezium. All right, and as far as key points are concerned, the one that I wrote down earlier. Okay, all right, now let's do part 2. Part 2 says, given that the distance traveled when the object is slowing down is 54 meters, find the average speed for the whole journey. So what is this giving us? Given that the distance traveled when the object is slowing down,
Total distance.
this is basically just the area of this triangle, area under the triangle. Okay, now if I want to calculate the distance covered from 0 to 6, what do I need to do? If I Yep, area. Okay, so why? Because area under the speed time graph gives you distance. So 36 times 6, which is equal to what? Which is equal to 216. Now can you tell me what is the total distance? Average speed equals total distance upon total time. So what's the total distance now?
270.
270. Very good. And what about the total time? 9 seconds. We figured that out earlier. So that gives us 30 meters per second. Okay, all good. But any questions, anything that's not clear, feel free to ask. Okay, I think आप लोगों की बस हो गई है कि आप सवाल भी नहीं पूछ रहे नहीं एक सवाल नहीं करते. Let's not push the limits. Let's stop here. Okay, and we have, okay, this, I'm not skipping anything. We have done the first 3 parts. Okay, now we will do conversion of graphs. I mean, now se mera matlab, not like now, but in the next class we will do conversion of graphs, and then we will do past paper questions. Okay, so I will share the past paper questions with you guys anyway. So if you guys want to try them, you can try them already, but we will do them in the next class. All right, so I'll stop here. Okay, so take care. Allah Hafiz.